How old is that?
What's that?
How old is that?
The street light?
Yeah,
It
82.
only came out like a year ago or something.
Oh, that particular model?
Yeah. There was a blue one of those.
Oh, because I was saying all the ones from the 80s were like kind of ribbon cable on them, right?
Oh, okay. Yes.
I would think so. They weren't wireless. Yeah.
Oh, this is new from
Okay, I've heard of that before. I've just never seen one.
So what sort of a wireless system is it using?
just Bluetooth.
It is Bluetooth?
Yeah.
Oh, is this how Vincent has figured out about Bluetooth to make that work?
So where's the Bluetooth? Oh,
That is great.
in here. Somewhere in there is a Bluetooth dongle, right?
At the back there, just serial to Bluetooth.
Right there.
Right back here.
Yeah.
Okay.
And we got the card going as well, so it's.
Cool.
Yes, it is.
So that's what it's drawing there?
Yeah, just people have been playing with it.
Yeah.
It helps me. Yeah, that's right. Yeah. I don't know whether it's moved in transit or whatever. I guess I need
Good evening. We're now at the point of KFest where the HackFest entrance will display their HackFest entries. There is no the order of the participants who are showing their entries have no is not any is a random order and nothing hurts to say the first part of this. So, but to get things started, we're going to have Jeremy Rand show off his entry, and I'll let you introduce it and show us, please.
So I've shown a few people here this device that I have in my hand. It's a Curta mechanical calculator. It's from the 50s and 60s. You know, and there's been a lot of emulators of the Apple II written, and so I thought it was time the Apple II emulated something else. So here's some hardware that predates it.
Cool.
And so I wrote a simulation of it. So to understand it, you kind of have to know what this thing does. What you've got here is a series of dials, and I can put a number in here, say 54. So I've slid 2 sliders down to make 54. I can do the same thing in the app. You have to imagine I've got a joystick. I've got the arrow keys on the emulator. So I'm running the Apple II emulator here. The arrow keys in the emulator emulating the joystick. So what the action I'm actually going to be doing is pulling down on the joystick and releasing. So if I go pull down and release a series of times, I got a nice little click like the sliders do. And then I can shift over to the next row by, again, another little kind of gesture sideways, and then down again. So there's 54. So I've got 54 there. On the actual calculator, if I want to multiply that by 4, say, then I would just crank this crank at the top 4 times around. 1, 2, 3, 4. So I've got 54 times, it actually says 4 there, is 216. On the emulator, again, you have to imagine a joystick. What it would look like is going around the outside of the joystick. So if I kind of make that motion in the my Apple II emulator, there we go. That's once around. Slow down twice. There's a little sound to kind of emulate the kind of sound that the device itself makes. So there's 216 as a result, same as the calculator. So 54 times 4, the counter, is 216. It'll do a subtract. So on the actual device, you can pull up on it, and then go around again. So that would subtract 1. So now I've got 54 times 3 is 162. On the actual Apple, it'd be like pressing the joystick button and then going around. Oops, I messed up. And I don't know if you heard the device, it made kind of a louder, crunchier sound, so I kind of tried to emulate that too. So I've got 3 times 54 is 162, same answer. Now if you want to multiply by 100, you don't have to go around 100 times on the actual calculator. So I've got 3 times 54 is 162. If I wanted that to be 203, for example, I can pick up the top here and rotate it so it's at the hundreds column. And then if I go around twice, that's like multiplying by 200. So if I do that, 1, 2, I get 203 times 54 is 10,962. So on the actual, my emulation of that, if you hold down the joystick button and then shift over, you'll see this little caret at the bottom move. So now the caret's at the hundreds position. So now if I go around twice, I get 10,962, same number. And I think we're pretty much done our calculations for now. So on the actual device, if I want to kind of clear it out, I lift the top here and I spin it, and it makes 2 kind of little clicky sounds. So on the emulation of that, if you press down the second joystick button and then go around, it emulates that.
So that represents 54 by 203.
That's right.
And when you do the calculations, are you actually using the normal calculator on the computer, or are you actually imitating the methods used?
Oh, I'm not emulating like the gears or anything like that. This is not, this is, you know, I'm just doing the arithmetic. Yeah, you don't want to open one of these up. It's a mess of gears.
When you cleared it out, was that supposed to clear out the 54 also, or do you have to clear those separately?
So on the actual device, to clear the 54, you have to slide them up. So, you know, we can do that here by sliding them up.
All right.
And you know, through these basic things, you can do addition, subtraction, multiplication, and division. You know, there's ways of doing all those things, those operations. And that's basically it.
So who's going to be next for showing?
Oh, you want to say what you wrote that in?
Oh, sure. I use CC65 on the Mac, cross-compiling to Apple II.
Nice.
Good job, Jeremy.
CC65 is available on
So,
Not
You have to use it on
sure,
Mac.
let's go ahead. Sure.
you can use it on like
We need
Linux
to
platform.
bring. So it's going to be dragged up a little bit to get the screen to the projector. Cable to float over.
Is there a way to connect this
I'll
to
say-
a composite?
Yeah, it's black and white, only
Well, yeah, I know, but we'll at least see what it looks like. Explain that it's not quite.
Does anybody have a composite cable down here?
Yeah, I've got one.
there's
one. I got one. There's one on that
So
monitor.
while they're setting things up, I
So
do
one on
want to
that
make a
monitor.
note that
What's
there
that?
is,
What do they cost?
that there's several
Is it
of
still
the
there on the monitor?
HackFest projects have some heavy math intensive stuff. We saw one from Jeremy already. And so we'll see a cross of some that are heavy math, some that are more fun. And I will announce which ones are which. We'll let every participant display what they do. So it's actually pretty cool to see such a wide variety of projects this year. So with that being said, they'll be almost ready to show us the demo. They're going to have to figure out how to get the right software loaded up. So I'm sure they'll take another minute or two. And when they're ready, we'll see the demo.
So, I've always wanted to
Excuse me,
spend some serious time with an Apple III, so I arranged with Mike to spend 2 or 3 hours in his room. And I learned Business Basic, and I learned how to do graphics on the Apple III, which is radically different than how graphics are done in AppleSoft. But learned a lot of interesting stuff about Business Basic. It's pretty neat, and quite powerful. And also the repeat keys are really cool. The arrow keys, if you hold them down, they repeat slowly, and if you hold them down harder, they repeat faster. It has nothing to do with my entry, which is just a simple, basically crack screen kind of thing. Done using graphics commands in Business Basic. Some greets, I misspelled cruise handle, my apologies. And,
But this does show in color on a real Apple III.
Oh,
So the T is actually.
There's a T there, it's just
there is
dark
a
on
T,
this.
it's just not showing it
We
very well.
realize that this demo is not quite accurate, but please, after, outside of, our demonstration, want to see it, I'm sure Martin and Mike will let it be shown.
So that's it.
All right, Mike. Thanks a lot. So it's interesting, we had 2 Apple III HackFest projects this year.
and are on any platform of one's choosing.
These are Apple III specific HackFest projects. They're leveraging, well, we know so far that Martin is leveraging Business Basic, which is only an Apple III based language. We'll let Mike describe what he has done.
Can you turn down the lights?
Hey, Carrington, can you get the lights?
Text obviously isn't very good. Basically, Martin did graphics in Business Basic. I did sound in Business Basic. The Apple III has 8 octaves.
It goes off the direction.
Of,
Turn off.
That's good.
the Apple III has 8 octaves of sound and voices, and so all I did was, this is just a simple tone generator based by choosing 1 through 8. You can choose the octave you want to hear the music in, and then hitting the various keys, you can generate the tones.
It's broken. So it's. Leave the one open.
Want to explain which keys you're hitting to play?
I tried to lay it out a little bit like a real piano. So for A, you get your natural A, and then for the A sharp is W because it's up and to the right on the keyboard. So that's really all it is.
Great. Thank you. Cool.
I got my laptop up there.
All right. Thank you, Jeff, for being our next participant to demonstrate. So we had 7 participants this year, and Jeff is our 4th one to show right now.
By the way, did anybody drop a entry card?
Someone's sitting over here. It's over
5,
here.
6, 7 is written on your sticker. I get paid $40 then.
This isn't what I initially planned on doing,
Over there.
It was over here.
Yeah.
but my assembly skills are so rusty, I decided I should go for something a little simpler. But this is actually based on the game I saw. It was posted to the Kansas Apple II news groups a few years ago when I was still active there. And he had written this game for the Apple II, and it was one that he had played on his phone, I believe. I think it was his girlfriend was a big fan. So he had written it for his girlfriend. But I decided that, I'm not just going to recreate it, I'm going to, embellish it. So I took his game, which basically is, all it is a field of colored blocks, and it will flood fill from the top left corner with a new color that you choose. And the object is to fill the entire field with one color and the least number of moves. And so I took that and decided, let's make it so you can do tournament play. So you can have up to 9 people play the same board and see who gets the lowest score. You can also set the size of the board from, right now I'll just do a 1 player. The board can be 5 by 5 up to 36 by 36. Right now you want to keep it to the smaller sizes because all of the fill routine is written in AppleSoft. So it's a little slow, it can be optimized though. So I'll do a 10 by 10 order right now. And then I believe he had used a fixed number of colors. I allow you to choose any number from 4 to 16. And for demonstration purposes, I'll just go with 4. And the other thing I thought to make it a little more interesting, rather than always having the flood fill go from the top left corner, why not allow people to choose to have that corner move? It can start at the top left corner and then go clockwise around the corners, or you can just have it randomly pick a corner and you have to flood fill from there. It just makes you have to think a little more. I'll just do the fixed one for now. Okay? And there's a gray dot up in the top left corner to tell me that's where it's flood filling from. I got a small menu down there to tell you what keys to press for the different colors. And so right now there's a red one in the corner with a blue one and a black one beside it. I want to pick blue or black to make that corner section bigger. So right now I'll pick blue. So now it's 2 blocks tall, and I've used 1 move. This is something I didn't tell the judges. I actually have code in here to handle this. If I pick another color, and now it has the plural. I actually added that in just for the heck of it. But yes, and you just keep doing this until you've filled in the entire thing. I'm picking, so now I'll pick red. I'll pick, what would be good here? Probably pink, and some blue, and more pink, more blue, pink again, some red, pink, blue, and black. Oh, I missed one in the corner. There we go. I won in 15 moves. So I press the key and it brings me back to the main menu. We can start again. So just so you can see what it's like, I'll just select a small 5x5 board with 4 colors with 2 players. And I'll pick the clockwise one this time just so you can see it. So that's player 1's turn. So they get to play the entire board and see how many moves it takes them. So 2, and then it's over. Now the gray dot has moved to the right corner, so it's filling from over there. So I'm going to pick red, and we'll go blue, and blue. Oh, that was red. Whoops, hit the wrong key. So I'll go red there, and now we'll go blue there, and red, blue. So it took player 1 10 moves. Now it's player 2's turn, and I can sit here and just play around for a bit and make sure that this player gets a very high score. Okay? Make sure one of them wins. At the end of that, it gives you a breakdown of how many moves it took each player and which player won. If there is more than 1 player that has the same number of moves, the lowest number, it will tell you how many people tied. That's it.
What's the name of that game?
I call it Colourfill.
So Jeff has a working game.
You spelled it funny.
All right, so it looks like Scott is ready to.
Sure.
Got a computer? Yes.
You spelled color wrong.
You need to turn that on. Oh, I'm moving around.
Yeah.
Nice job, Jeff.
You. It's with the U and color.
That's the way it's spelled.
You're British.
It's not color. It's
Yeah, we're searching for it.
This one is Dudley D. Wright.
Give us a
One long
People who give us
So you should
The Canadians actually
You're a
don't
signal.
United States
Is that true?
ads, you know. When we decided to make why would you add it? I don't understand why, you know.
You wanted the corner of the
You can wait.
Yeah.
We want more beaver pelt.
It's actually pretty impressive because while we're waiting for this to boot, I want to explain that this computer is very special. In fact, it's far more special than any computer in Tony's collection. This is the computer I begged and borrowed and stole to get my parents to buy for me when I was like 8 years old. So this is the most special computer in the world, at least to me.
Of course, it helps that I can remember my commands. Let's see.
What's that smoke?
So I'm going to gloss over a lot of the stuff. I did do a sort of math-intensive entry. There's a concept in mathematics that with any irrational number, of which like e and pi are examples of which, if you carry them out to enough digits, you can find any number. You can find, there are websites out there you can find your birthday in pi. And so the concept is that in any kind of formula or something that generates, you know, a sequence of numbers, you could use that for, say, a compression algorithm, where you could find some numbers that you want, find a pattern generator, and then all you need are the inputs to the pattern generator, and you can encode a whole bunch of stuff. So I graphed out a pattern. It has 53 points on it, and I thought, okay, so, and then I wrote a pattern generator and searched the pattern to find a bunch of sequences of 10 digits in a row that would match my pattern. And by doing that, I was able to compress essentially my points. Now with 53 points, you have two values, an X and a Y. So there's 106 values. And of course, didn't think about it when the judging was going on, but in the end, I did count it afterwards, and there's 33 parameters in my program. So it's a compression ratio of just a little better than 3 to 1. But it would probably be even better if I was doing a larger pattern. But of course, with HackFest, you know, there's only so many hours in a day, so I had to keep the pattern simple. So I'm going to go ahead and run this. And my program's filling in my pattern. And the scary part about this is when you're coding it at 2 in the morning, it doesn't look anything like what you wanted until you get really close to being done. And it's filling in with sort of random colors and redrawing some of the patterns. But eventually it fills in the pattern to spell KFest 12. So the code to do this, I got. Oh yeah. You can tell I don't do this every day. So here's the first part of my code. You know, I'm going down to the bottom. With AppleSoft, of course, you know that you get the best performance out of the early lines. Let's say lines 11 through 55 is the pattern generator. And so it's kind of similar to, well, it's kind of complicated, but it's sort of similar to a crazy random number generator. And lines 80 through 110 take the single numbers that come out of that and demux them, I guess it is, or something. Basically, it takes that single value and turns it into an X and a Y. So I can get, for each number on my pattern generator, I can get 2 points to plot. And so then it plots all that. And then let's see. The rest of the program is that. Oh, hey, we should probably do. I don't know if this will look very good with that. So you can roughly see the structure here. It's basically plotting in my values and then doing a GOSUB. There's extra values because I'm changing the colors every so often because I can. But if you count all the parameters, which I did, to get 106 values, I only had to enter 33. So that's my program.
Okay, let's see. Ivan, want to be next?
Sure.
And then we'll do Peter at last but not least.
I can't give this back, sorry. Oh, yeah, you might have the video.
Got the VGA phone?
Do you have second screen labels on the back?
Yeah, I do. I guess I can go stick this on the second screen wherever the Zorg is. Wait.
Oh, it's to the left of your main screen.
You're right. Alright, now if I go full screen here, will it do this? No, it does that locally. Alright, I'll just make it big. Sorry, I'm slightly mouse disoriented at the moment, but once we kick it out with 2 style, it'll be good. That's too big.
I just set it to mirror the monitors.
Oh, that's a smart idea. Indulge me one moment while I do that, please. Much better. Okay. I'm introducing, this is my very first HackFest entry ever. I'm introducing a brand new AppleSoft programmer utility called Magic GOSUB. 100 years ago, I developed say about 4 years ago, I came up with the idea of returning to AppleSoft, and I realized I wanted to write it in an editor, and I wanted to write it in a much more structured way, built around subroutines, than using a bunch of GOSUBs. And what I discovered was that having to GOSUB to line numbers all the time was annoying, as opposed to being able to GOSUB to labels like you can in more modern languages. So I really wanted to be able to GOSUB to labels, and that's what Magic GOSUB lets you do by exploiting a flaw, or a behavior anyway, in AppleSoft that I discovered, which is that if you go to or you GOSUB what appears to be a variable name or just some general text, it will in fact GOSUB 0. So I took advantage of this to write a very small machine language routine that will catch that and allow you to GOSUB a label. So let me quickly demo it. So I'm beloading Magic GOSUB, which your program would do. The first line of your program needs to actually call Magic GOSUB. Let me actually just make sure. It is actually totally relocatable. You can stick it wherever you want in memory. It also does fit at 300 without overwriting anything. So your program would do that. First line of your program is going to be call Magic GOSUB because that's where it's actually going to go when you GOSUB. We can then go 100 starting, 110, GOSUB my sub, we're going to call it. 120, done with GOSUB, 999 end, and then let's make our subroutine at, doesn't really matter what the line number is, let's make it 5,000. We're going to, you need to do a rem statement, and then sub with a caret, and then the label for your subroutine, which is going to be my sub in this case. So then let's have it do something cute, or quick anyway. Okay, subroutine done. All right, so here is our whole program, and when let's try it out and hope it works. Oh, it does work, which is nice. I like it when things actually work. So that's it. There's no line number on the GOSUB. It's just my sub, and it finds my sub wherever it happens to be in the program. You can do that with as many target labels as you like. There's no nesting. It doesn't hack AppleSoft. It just exploits this one behavior in AppleSoft that if you GOSUB to something in text that it doesn't understand, it will in fact GOSUB 0. Post-judging, I did actually add a couple of features, one of which is if you, where do we have, so if we change 110 to GOSUB foo and you can't find foo, it will actually give you the right error with the right line number, that it can't find your label. And then the other thing it can do, this is, I'm calling the Stavros feature, is we can now have magic go to, which I didn't think was possible because I depend on the stack to know where I am. But if you poke 214, 255 before you call magic GOSUB. Whoops, I'm sorry, before you just simply do your GOSUB. That is going to make it a magic go-to because it removes the GOSUB return information off the stack. So we type run and we're going to get a return without GOSUB error because it's not a GOSUB, it's a go-to now. Anything else I can tell you about it? Oh, it's also totally Slammer compatible, of course. In fact, Slammer was invented to accommodate Magic GOSUB, even though I never wrote Magic GOSUB until today. Because I didn't like the idea of having to beload something every time out. So for those of you who are unfamiliar with Slammer, the whole thing about Slammer is that you can put machine language into a regular AppleSoft program so that you don't need to beload stuff. It does mean that there's some, weird looking stuff in your AppleSoft program like these for line 0 through 9. And then we've also got a subroutine here that contains the actual magic GOSUB hex dump. But your actual program can live happily from lines 10 to 62999 or whatever. There it is. So here we do not need to beload. This can be your whole program. You can distribute it as just a pure AppleSoft file, and you have magic GOSUB at your disposal. So that and because it's totally relocatable, it also can use a Slammer feature where it will stash magic GOSUB between the end of your program and the start of variable space. So that way you can put it in a spot of memory where it's out of harm's way if you, for example, want to use 300 for something else. That's it. Any questions?
Yeah, what if you have a variable, like in this case with my sub, if you have a variable defined as my with a value, does that screw it up because it tries?
No, it's gonna have no idea.
Yeah, okay.
You could, in fact, there could be a variable called, the one issue you can run into is that you can't have anything as part of your label or as your label that AppleSoft recognizes as a token. So you probably don't want GOSUB, what? Yeah, so you probably can't go GOSUB tone. GOSUB tone. Let's take a look at that. You'll see that AppleSoft thinks 2 is a token, and that's going to break things. So you need to look at your list and make sure that AppleSoft hasn't tried to parse what you've given the GOSUB label. But other from that, it works. Any other questions?
Thank you, Ivan.
Probably.
Thank you, Ivan. And we'll now have Peter to his presentation. This is going to be Peter is our final HackFest entrant, and his is also going to run on a real computer.
No worries.
Nope, you turn the screen a bit. There you go.
I picked up this 2C a couple of weeks ago off of Craigslist. It came with a 2C, a monitor, the original set of discs that came with the 2C from about 1984. My initial goal for HackFest was to do something using just what would have come in the box when you bought the 2C in 1984. Walking down the hallway at KFest, I found a mouse in John's giveaway box from, I believe it was Stavros. So thank you, and I decided to integrate a mouse. I have never done mouse programming. I've always wanted to own a mouse for my Apple IIc Plus, which I did bring with me. At that time, I used a joystick to emulate a mouse because that's the best I had. So I had fun learning how to program a mouse as well. This disc came in the box that I got with the 2C, and I'm stuck with ProDOS Basic 1 and ProDOS 1.0.2 because that's what was on the system disk that was in the box. I wrote a small Lissajous function plotter. Lissajous curve is a parametrically defined mathematical curve that produces surprisingly complicated, interesting curves. These patterns occur in a number of different circumstances, such as Lorentz knots. There we go. You see the parametric equation at the bottom? 3 parameters to the equation. The parameters don't quite match the variable names that I used in the equation in the last line because I changed the form of the equation during testing and neglected to update the text, but the equation I use is equivalent to that. Move the mouse to manipulate the B and C parameters. And wait, it's in BASIC, so it takes a little while. Think of it as a mathematical etch-a-sketch using the mouse. Any questions? That's it, using the mouse firmware.
Great. All right, so as I got closer to the room, so now we're going to, the judges have deliberated. The judges was myself, Sean, and Dr. Steve, and we're going to announce well, with 7 entrants, we're going to announce the top 3. There's going to be 1 honorable mention, and we'll, of course, we'll congratulate everybody else who participated. So, working backwards, the 3rd place winner is going to be Ivan with his Applesoft label GOSUB go-to.
Magic GOSUB.
Number 2 goes to a what I would have considered a surprise, Jeff Blakeney for his Colourfill game. And our number 1 recipient is Jeremy for his Curta. Thank you, yeah. And honorable mention goes to Scott. It was an incredibly fascinating mathematical set of operations. Most of the judges were talked over his head, but I thought it was extremely an impressive work that he had done. And yeah, with the 1-to-3 compression, yes, it was a great skill, great HackFest. So, and Ken will talk. So, someone will talk about prizes.
Yes.
Canadian 1-2.